Hello everyone, here I will explain and present the results of my midterm project for Introduction to Computer Science. I will explain in outline first why I chose this topic. Previously, the topic that I will take and will make is how to get the type of relative density of a soil. This topic is related to civil engineering and I happen to be studying this topic this semester. So I want to make a code to make it easier for us to find the type of relative density of a soil. So my problem description is, within the world of civil engineering, proper knowledge on relative density, also called as density index, is important. This is due to the property of granular soil like sand and gravel can differ from places to places. When choosing a place as a foundation for a building, loose soils can settle a lot after a building is placed on them, causing cracks or even collapse. There is a formula that can help calculate the relative density with enough data like specific gravity or GS, the dry density, or we can call it rho d, and rho d in the loosest state, we can call it rho d min or minimum, and the densest state or rho d in the maximum, with the unit weight of water being gamma W equals to 9.81 kilonewton per over meter to the power meter cubic. The formula is shown below, right here. To detect their relative density and help engineers save time, I will make a Python program that can tell precisely the state of any given soil based on the table below. The table is right here. So when the relative density is below or less than 15, it will be very loose, or if it's between 15 to 35, it is loose, and between 35 and 65 it will be a medium state, and in 65 to 85% it's a dense state, and above 85 it's a very dense state. As you can see, this is the equation, and the purpose of my problem is, as I said earlier, for beginner Python programmer and civil engineer, this problem will help them understand how to calculate the relative density of a soil while teaching them how to use conditional statements in Python using the available functions within Python library. And this practice problem will also help them understand in choosing the upper and lower bound of the conditional statement for accuracy and avoid edge cases. So this code that I make is very basic and very beginner friendly. So what do we must input? We must input the specific gravity, the dry density in the loosest condition, and the dry density in the densest condition. So this data will be given in the question, and the output will be the relative density, like what state of the relative density of the soil based on the table above. So I have made a sample question here. A dry sand sample has a dry density of 15.8 kilonewton over meter cubic with a specific gravity of 2.65. This sand is hmm? Oh well, the dry density when it is in the loosest state is 13 kilonewton over meter cubic, and when it is in the densest condition, the dry density will become 17.2. Using the given data, please classify its density conditions. So we will input the specific gravity, the dry density in the loosest state, and the densest state. In the question, there is a mistyping here, so there should be 15.8 here, and the sample output should be loose. This is the code solution. So I will try to do it one more time here. I will run my code here. Then the GS is wait a minute. The GS will be 2.65, and then the dry density will be 15.8. In the looser state will be 13, and the denser state will be 17.2, and the answer will be loose. And we need to remember that the dry density the unit must be in kilonewton over meter cubic. Okay, that's all for my midterm project. Thank you.